Hi, I'm Tim. Join me in this video as I go through how you can build from plans you can download on the description this 1908 Antoinette monoplane from 3/16 inch foam board. Let's get to it. In this video, I'm going to try to build a foam board model of the Antoinette monoplane. The Antoinette monoplane was a French design. It was a series of aircraft between 1908 and 1910 by Leon Lavoisier in France, trying to figure out in those early days of flight just how you build an airplane. What does an airplane look like? It's an attractive airplane. Everybody pretty much knows what the Antoinette looks like. And it has surprisingly modern features with a tractor motor, a monoplane wing in an age of biplanes. The pilot tail surfaces is a very conventional looking airplane. And so there were a series of Antoinettes, 1 through about 9 or 10. They experimented with different control surfaces, wing warpings, ailerons, engines, just trying to figure out how to make this thing work. And the big thing back in those days, the newspapers would often offer prizes for like crossing the English Channel. That was one of the goals of the design. Blériot beat them on that. But it's interesting to look into the contest. The Antoinette won a 1909 flying contest with an altitude of 500 feet and a max speed of 43 miles an hour. That won the prize for back there. So what I'm doing in this one is, I'll show a picture up here, but I just downloaded a 3-view of the Antoinette, and you can take a close-up look at this right here. This is available for download from the description in the YouTube video. And what I do, like I did with the Lazy Bee, when you have a design like the Antoinette that has a lot of straight lines, I simply take this, I figure out what my wingspan would like to be, and I have a multiplication factor. What I came up with on this one is every dimension on this plan, I just multiply by 5, and I get the full-size design. So for example, the wingspan will be 20 inches, 6.25 inches. I just measure that out, I draw it onto the foam board, cut it out, and build it. So I plan on using normal 3/16 inch width foam board. I got mine off of Amazon and a dollar store. I intend to keep the paper on here because it looks a little bit nicer. It accepts the acrylic poster board paint. If it flies well, I'll go ahead and paint it up, see how that works. And for the controls, I'm just using absolutely normal controls. The Park 250 motor, all in the description. Servos, it'll be a 3-channel model for ailerons, elevator, and throttle. There'll be no rudder on this one. There's no tail wheel. I found a couple spoke wheels just in my parts bin here. And one of the initial challenges of the Antoinette is the fuselage, because it's a very lightweight aircraft. The whole airplane weighed about 1,500 pounds with a very heavy motor. It's a triangular cross shape. The triangular cross shape was common to a lot of these early airplanes just to save weight. It's tricky to build for an RC model if you have to do it by wood. People obviously have done it, but what I'm going to do is, because I was concerned about the triangular shape of the fuselage, I normally do the wings first. I did the fuselage first. So here is the fuselage here. It's 33 inches long. You can see that it is a triangular shape. This is the nose right here. This is the top. There is a cutout on the back for the tail surfaces that I've already prepared here. And so the stabilizer will go on like this. The rudder, fin and rudder will go on like this. Again, no rudder control. And then the bottom of the rudder like this. For the woodwork on the landing gear and on back, I have these bamboo skewers. I think they're used for cocktails to put olives on or whatever. These are pretty easy to work with. You can bend them, reinforce them with thin CA glue. I think that will be helpful. We'll see how that works out. And To make the fuselage, I'll show more details after this in the assembly process, but I just built some triangular formers. You can see one in the nose section here, that triangular former, just to give shape to the fuselage. It was kind of a cut and fit process. I used some Elmer's wood filler in here to fill out the gaps. I think that came out pretty well. And this is the fuselage. I'll have to cut out some openings here as I put on the wings for access to electronics. The idea of building this is to A, see if it'll fly, and just see where things work out with the center of gravity, with the motor, the battery placement, to see if we get something to fly properly on this. So I'm pretty happy with the fuselage. It's a surprisingly strong fuselage with a triangular shape. I'm very happy with that. It's not too heavy. So the next step will be to do the wings. The wings, I will use an airfoil for that. I think you could probably get away with a flat airfoil. I want to try a flat wing. I think I'm going to try an airfoil on this one. And the other thing that's a little bit distinctive, I'll put a picture up here, but with the wing on the Antoinette, what happens is it's completely open on this fuselage and the rigging hold the wings in place. So I'm going to try to avoid joining the two wing halves. It's just not going to look right. I'll keep them separated on the fuselage. I think I can do that with a lightweight model like this. Again, I'm going to use some carbon rods for that and the skewers. I think I'll be able to get away with that gap in the two wing halves for this fairly lightweight model. So the wing is next, and we'll keep you updated with that as we progress with the build. Thank you, as always, for likes, subscribes, as well as a super thanks. Thank you very much. They do help the channel a lot. I made some paper full-scale templates for the top of the fuselage and the side panels. Again, just measuring off the plans, multiplying by 5 the measurements I got, so it's going to be close enough. Cheated a little bit to make them a little bit wider than necessary for room. You can see triangular shapes for the formers. That gives something to glue the sides again to form the fuselage. This is a front view of the fuselage. You can see the interior. The tail still has to be glued together. And here is the finished fuselage, the 30-inch section. And you can see I put the top on the formers in front, and just a view of the fuselage. The gaps will be filled in with Elmer's wood filler compound. Here's a completed fuselage. You can see the forward 3 inches added for the nose and little reinforcing straps to make it a little bit stronger, because the foam board is only 30 inches long, but the fuselage measured out to 33 inches long. Another view of the plans that I downloaded from the internet. Here are my marks in blue ink multiplied by 5. So if it's 2 inches on the plan times 5, it'd be 10 inches to sketch out on the foam board for the full-size plan. This is just sketching out the tail surfaces, vertical and horizontal. Just drew it on with pencil, put it in with ink. And here's the cutout pieces. I just kept it the way it was. This is the original elevator. The other one was a little bit bigger. I thought that was too small. Same thing for measuring out the 2 wing panels, straight lines. Just measured the root and tip section. I just sketched in the airfoil shape and measured the measure off the wing for the end, middle, and tip of the wing. This is the airfoils glued in. I'll show you later in the video how to cut the foam board to allow it to be curved. Little slot for the 2mm carbon fiber rod to add strength to the wing panel. These are the 2 wing panels. You can see the little cuts that I did on the underside to allow the wing to be bent over the airfoil shape when I glue in the airfoil. And here's one wing panel with the slots, and the other one where I've glued on the ribs. You can see how they just glued on pretty well to give the wing an overall airfoil shape. Here is a spacer, because I'm going to keep the 2 wing panels open per the real Antoinette, some overlap with the carbon rods. And this is just what it's going to look like per the top of the fuselage. A sketch of the landing gear. Again, just drew this from the plan. Bent it with fairly small music wire just for easy to bend. The plane was fairly light, didn't think it needed to be overly strong. The landing gear is glued into a slot on the bottom of the fuselage with epoxy. When I flip it over, you'll see that there is some plywood reinforcing for that landing gear. You can see in the top of the fuselage, I just cut squares to have access to the interior for the electronic speed control, receiver, various wires. And the motor is in place on the front, just a simple plywood glued in place for the firewall. Here's another view of the fuselage coming along with the bamboo skewers glued in place with epoxy. Not a real robust structure. It is going to be fragile, but I just wanted to put it in place to see how it worked out for this prototype. Landing gear in place with the bamboo, the rudder servo on the top, and the tail surface. Here the vertical tails are in place. I just have a movable elevator and ailerons. The rudders do not move with a bamboo skid underneath. Obviously you're going to have a hand launch of this. There's no way to taxi it on the ground. Note also the balsa, 1/8 inch balsa for the leading edge of the wing incidence, and the rudder servo in place. The tail surfaces, controls are just held in place with masking tape just to see what they look like at this stage. This is the initial joining of the wing halves with the skewers. You can see the foam board spacer in place so they're the proper distance apart. And again, this is just an experiment to see how well it holds. This is 1 inch dihedral on each tip. And you'll see with the eventual crash of the airplane, this is the failure point right here with the skids. With the bamboo skewers, I did not have enough strength. I've completed the Antoinette's wing, and I want to walk you through what I did because I made this up. I haven't seen this anywhere else. So here are the two wing panels. As I mentioned, they're 20 inches long. And I just measured off the plan to get the width of the tips. But as I mentioned on the Antoinette, the open section by the fuselage, it is open. The wings don't connect. It's just the way they built it back then. The flying wires held everything in place. So what to do? So what I did was I built the two wing halves. I propped them up with foam, about 1 inch dihedral, and just picked up that number. And with the bamboo skewers, what happens, you can bend these slightly. See how you can bend them like this and it still holds everything together. That's the dihedral that I did. I just did 4 of those right here. This is the overlap of the carbon rods that provide strength to the wing. And on one half, I epoxied in the bamboo rods on this side, put everything in place, just slipped it in, and then tack glued it with epoxy on the outside. These are not glued yet. Tomorrow, I'll glue all these to the wing. I'll tape it down as a little bit of reinforcement. And if I think I need more strength, I can add more skewers. But I think this, we'll have to see. I'll probably add a few more. I think if I double up the skewers along here, that'll really make it stronger because this has to hold everything when the wing's flying. So that's that. And then to show how that works, this is a fuselage, the top of the fuselage. The idea is this goes something like this. And that will be the wing. I'll just have to check to make sure I have the proper incidence. We do want a little bit of positive incidence pointed up like that, but I can work that as I get the final seating. I may have to shim it up a little bit with the foam board to get the incidence. But that's the wing right there, and we'll go ahead and work on that tomorrow, again, with a little bit of the airfoil shape there. So continuing with the fuselage build, you can see the filler for the gaps in the fuselage. That's the nose. This is the beginning of the firewall for the motor. Just a simple 1/16 inch plywood with 4 screws holding it in place. Little slot in the bottom for the wires to fit into the fuselage itself. Not a lot of room in there, but again, this is just a prototype to see how the things work and fit out. Putting in some of the components, the electronic speed control, the battery will go here. Originally a 2-cell battery. I needed more nose weight, so I went with a flying model to a 3-cell battery just for a little bit additional weight. There's the rudder servo, the elevator servo, just hot glued in place, nothing fancy there. Trial fitting the electronics, some tape to hold the wires to the motor in place, and just coming along. These are the aileron servos, HS40 servos, small ones. In the ailerons, hot glued in place on top with connectors. Nothing very fancy on that. And there are the bamboo skewers glued on both sides. It felt pretty strong at this point, and I think it would have been okay for a lighter weight model. What you'll find is I'm going to eventually have to add a lot of nose weight on this to make it balance out, and that weight is where we come into problems with a with a model flying itself. I'm complete with the Antoinette, so let's take a look at it. The total weight with the 3-cell battery that I decided to use was 1 pound 5 ounces. So heavy, but that's what it was. Again, I had to add a ton of nose weight. You can see all these sinkers. It just hurt me to do this, but these are epoxied in to do. If you do your version, make the nose about an inch, inch and a half longer. Use the weight of the motor, the battery further forward, so you don't have to add this extra weight, but I did for this one. I painted it with red poster paint because that's the paint I had. I think it looks relatively okay. It's 3 channels with the aileron servos here. Put the control horns on top just to make it easy. And the elevator servo along here to the elevator. No rudder. And I've glued on the wings. I decided that's the easiest thing to do. The 3-cell battery is a little bit heavier, so I'm going to put that up front. In a moment, we'll hook up the battery. You can see how that works. Here's the stuff inside. The electronic speed control is right here. The receiver, and then the aileron servos just plug in through a Y cord. So that is the model. You can see the underside. As I mentioned, the one thing that really caught me short is the center of gravity is about here, the standard 25% on the wing. You'll notice the main gear is behind the center of gravity. Well, if the center of gravity is here, it's going to rest on the center of gravity, but there's no nose gear on just that forward skid. I don't know what happened on the full-scale Antoinette to allow them to operate with the wheels that far back, unless it was some really weird aft center of gravity in those early days of aeronautics that I don't know about. Also, you'll notice on this, the landing gear is pretty flimsy. I think when this flies to the landing, because it's going to go to the nose, it's probably going to rip right off. So if that happens, I'll probably relocate the nose gear further forward ahead of the center of gravity just to let it rest normally on the tail. It'll look a little bit odd, but that's all I could think of. You'll notice also the landing gear is very narrow. These early airplanes had minimum time on the ground. There was no steerable tail skids. They couldn't taxi at all. They were always in a field. Ground crews would point them into the wind, and they would just go full throttle to take off into the wind. They just couldn't maneuver on the ground. So there's a pretty flimsy, small, narrow landing gear here, but that's the way the original was. So why don't we take a moment to hook up the battery. You can see the control surfaces and the motor, and then I think we're just waiting for a good weather day. We'll head out to the field. Again, nothing super fancy in the battery. This is a prototype. I'm just going to use masking tape to hold that in place as far forward as I can. And I'll go ahead and take a look at the elevator. Up, down. Hopefully that's enough. Ailerons should be enough. And there's plenty of power with that 3-cell battery, so I'm going to make sure it's not blowing anything too much. So because the fact of the tail skid onto the nose is going to have to be a hand launch, it's going to have to be a pretty fast, aggressive hand launch to make sure it has airspeed after takeoff. But I think with a high throttle setting, it should be okay, but that's just where we are. I'd much rather take it off from the ground. Cannot do it because of that aft landing gear location. We're out here at the field for the test flight of the Antoinette. So here's the model right here, and I think everything's in place. As I mentioned during the build process, the landing gear is behind the wing center of gravity, so it's going to rest on the skid, so it's got to be a hand launch. The weather looks good for this. We'll put the battery, we'll tape it in, check the controls, the motor, and see how it goes. So we'll give it a test flight and wish me luck. Okay, this is the No Kidding maiden flight. Takes off, tons of power, turn to the left, back to the right, going way too fast. I can see the wings flex right here. And now the wings fold, you can actually hear it, and the model goes down. Let's take a look at that again. This was the beginning of the hand launch. The 3-cell provided tons of power. This is about half throttle. It's just, I was afraid I was going to burn something up. Very carefully put down the transmitter, readjust how I'm holding the model so I can get a good hand launch, pick everything up so I don't bump the throttle, give it the hand launch, and we'll soon go into 50% speed, flying fine, Now we slow down to half speed. You can see the turn to the right. I'm throttling back, trying to bring it back to the field, and right at that turn I can see the wings flexing, the wings fold in half, and now it goes straight down. So that was that. Well, that was an interesting flight. I'm actually pretty happy. The plane flew, okay? It turned much easier to the left than to the right. As I did my first turn out, I had the 3-cell LiPo battery. It was tons of power for the motor. I was almost afraid I was going to burn something out. But I didn't want to do like with my F4 video where I didn't have enough power. The hand launch went okay, and it flew. I could see the wings flexing immediately on the first turn. I go, I do not have enough strength of the wings. At that same time, I was throttling it back, trying to get slower to bring it back. The wings folded, it went down. So it's a foam board model. It's a test to see how we can make something quickly out of foam board. I'm happy that it flew. I think it probably would have flown better, but here we can see it's just ridiculous. You need music wire or something for the two wings, or another thing is just to make it butted up like here as a continuous wing. The opening here looks good on the pictures, but I just think for this model, it's not necessary to do anything like that. Also, as I predicted, the foam is not strong, and with the this kind of weak skewers here in front, it's just going to get chewed up on the landing. So I think I will take this as a lesson learned. It was an interesting design experiment to make it from the drawing with a triangular fuselage. The wings, what I would say if somebody wants to do this again, for absolute certain, take this nose and extend it out 1.5 inches to 2 inches longer. That way your battery is going to be further forward for center of gravity purposes. You will not need all this extra weight if you just make the nose a little bit longer. When you make the nose longer, you can now move the gear further forward visually to look about the same because it's the same length, and you can have the landing gear in front of the center of gravity, which will make it fly a little bit better, which will make it look better and just make it a little bit more robust. So that's the fun of foam board. You can make models pretty quick. I will never make a separation for the wings again. Any wings will be glued, butted in, so we can put in the balsa spars and things of that nature. But everything else held out okay. It had plenty of elevator authority. The ailerons for sure, if you had rudder only, that would not be good. And that's where we are with this airplane. So that's part of the fun of designing RC airplanes. You learn some things, you have some great successes, others not so much, and we just move on to the next project.